I guess we'll then go to Jakub. Jakub, anytime you're ready.
Thank you very much, Felix. Thanks for having me here. Let me just share the slides. So I think I should start probably from the same place as Milena did, so by saying that I'm not a landscape modeler. I'm a statistical demographer. Although I realized it when I got the invitation to speak at this workshop, I realized that actually some of the modeling that we do in our team has to do something with landscape. So hence the theme about the 3 layers of landscape and how to connect them through modeling. So the idea, actually, the very concept of that came from the defense literature when there's talk about the interrelations between the physical landscape, the human landscape, and the information landscape. So the interesting part is actually what's happening and at the intersection of the 3 layers of the landscape as we have it. And as an illustration of that, what I'd like to show you is an agent-based model of migration, or precisely of migration route formation. So this is very much rooted in the analytical sociology or social simulation type of thinking that you've heard earlier during this workshop. But in particular, I mean, why do we look at migration? Why do we simulate migration? So this is an area where migration decisions are quite complex, quite complicated. The humans who migrate or who don't migrate exhibit high levels of agency, hence the use of agent-based models seems quite apt. The problem is that the migration processes, first, they're quite complex and to the influence of many factors and drivers. They're subject to high uncertainty levels as well, and yet they evade a theoretical description. And this is true for most of demography as a discipline. I mean, we are quite empirical rather than theoretical. But recently there has been a line or a stream of literature that was arguing for a greater theoretical engagement of demography through computer modeling and through formal simulation modeling in particular. So this is the high-level motivation. And specifically talking about migration, this is when we talk about the 3 main demographic processes: fertility, mortality, migration. Migration is the most uncertain and complex, and it does have to do with the fact that it is pretty much all of it is driven by some form of human agency and choice. So where we started working on that, I mean, the situation in the field was such that we have recent advances in agent-based modeling, the social simulation and analytical sociology paradigms that allow for capturing some of the complexity in a formal way. At the same time, we have had advances in statistics in the area of uncertainty quantification that actually allow us to analyze the complex models in a formal way. So the question then arose, why not to bring these 2 approaches together, and hence the project Bayesian agent-based population studies was born, that is funded by the European Research. So the work that I'd like to talk about is so the example will be a model of migration, or rather migration route formation, in particular with particular focus on the role of information transmission. And this is at this stage, what I'll be showing now is still a theoretical model. So it's a data-free model in a traditional sense, but I will still show the applicability of statistical tools for model analysis later on. This is with credit to Martin Hinch, who is the modeler. So how the model works. So basically, agents, so if migrants move through a landscape, so here is a landscape connection, an obvious one. The landscape consists in our case of cities and roads, but the agents are also embedded in the social world, in the social network, and they exchange the knowledge they have about the landscape with the members of the network. And they use the knowledge then to find the best path. The inspiration behind this setup was pretty much what was going on in the Western Balkans during the 2015-2016, the so-called migrant crisis. But well, we thought that actually the way the processes, the migration flows were following through the European landscape was quite interesting also from the modeling point of view, and also potentially from the policy. So how does information work in the model? So here's this other layer. Information in a very simplified form. Information can be about cities or about connections or roads or paths. Cities have qualities, or can think about conceptualizing it as a resource availability or other advantages that locations offer, whereas roads have friction. The agents have information that is not only about the feature of the landscape, but also they exhibit a certain trust, or level of uncertainty is the flip side. So the main message here is that information can be very much unreliable. How do agents learn? They learn about the landscape by either communicating with other agents, in which case both parties adjust the information estimates slightly, or depending on the starting position, they can adjust both the values of the estimates and the trust levels in different ways. Or they can learn by exploring the environment, in which case they do a local search of options and try to find out more about where they are, what the possibilities are. So the model has quite a few, despite being data-free and fully theoretical, has a few interesting outputs. And I focus in this talk, I'll just focus on a few that we picked for more detailed analysis. So one related to the behavior of agents, so proportion of time they were following the initial plan for traversing the landscape. The second one is sort of more macroscopic, related to the level of route concentration as measured by the standard deviation of the visits in all the links. The third one related to optimality of the route selection. And the fourth one related to the repeatability of the outcomes across different replicates. And these were the outputs that were of interest. But we have, as you can imagine, even with a model of that kind, we have quite a few free parameters to look at. So we started the analysis from 17 parameters, of which the initial analysis allowed us to boil down to 7 that were found to be of importance and worthy of further investigation. Of those 7, 5 were related to information exchange and 2 to exploration. So you that the behavior of the model is very much information driven, and this is a statistical result. This is not something that we anticipated when building them. And for the analysis of the model, we use the framework designed by Mark Kennedy, Antonio Hagen, and Jeremy Oakley in the early 2000s. So the framework based on Gaussian process emulators or meta models, build a statistical model of the relationships between inputs and outputs of the agent-based model. A bit more about this in a few slides' time. Just one more word about, or one more slide about pre-screening. So how we compressed this initial 17 parameters to 7. We used something that's called the literature on experimental design. That's called definitive screening design, that allows to look at the effects of different parameters on the model outputs and discard those that do not have or do not seem to have much interest. If you're interested more in that, then there's the papers by Johnson and Stein lay out the principles for these kind of applications. So the analysis of the model, the statistical analysis of the model, followed the Gaussian process framework. So we basically following the work by Tony O'Hagan and his authors, we assumed that output follows a multivariate normal distribution for the realization of our model, with a mean being a linear regression of the parameters with some hyperparameters, and then a conventional covariance matrix, basically the default option from the. So what this enabled us doing was to look at the relative influences of different parameters on the model outputs, and here you have the proportion of variance explained by different parameters of the 7 that we looked at in detail on the 4 outcome parameters. There are quite a few colors, but the main message is that what really matters for these 4 outputs is the way the agents exchange information with one another. So the exploration didn't feature very strongly in the outputs, whereas the different aspects of information exchange, with whom they exchange information, how they update the information when they do exchange it, mattered a lot. The Canadian O'Hagan framework also enabled us to carry out uncertainty analysis, so looking at the variance induced in the output induced by the individual input parameters, and look at that in comparison to the variance just by the randomness of the code of the agent-based model. In this case, the code variance hardly mattered. It was the most of the uncertainty generated by our model was due to input uncertainty for the parameters that we didn't know about. So here is just an example of what came out of it. The one example of a response surface looking at the mean frequency with which agents follow the initial plan for traversing the landscape. Another example for this time for the correlation with the optimal scenario. Again, similar message in that information matters. Total variance, total variability in the output due to input uncertainty rather than the variability of the computer code. And again, the mapping of a response surface allowed us to clearly see what's going on in different areas of the parameter space. So what does it mean in terms of okay, it's a theoretical model. It's at this stage it's a data-free model, but what we found quite interesting was that there is a very strong support for the role of information in the emergence of migrant routes through the landscape. So information is this connector between the landscape and between the physical landscape and the human-like landscape. At the same time, these routes under regular conditions can be suboptimal. So there is scope for infusing the system for potentially with more information and better information in order to get outcomes that are better for the migrants themselves and better for policymakers, who try to manage the flows. And of course, the great advantage of simulation models, as you have heard before, is that they allow examining the different scenarios in silico in a quasi-experimental setting. So this is still a work in progress. So what we're trying to do now is to bring in some empirical information and embed it in empirical information. Probably will be using the Syrian migration to Europe as an example, just because there is a wealth of different data sources. So I'm thinking back to the discussion earlier this afternoon and Lex's presentation about data. So when we started looking at that, we were surprised how many different small scale and larger scale data sources there are available already on Syrian migration and Syrian migrants to Europe. the overarching idea is to embed everything in the framework of the Bayesian experimental design that would hopefully allow us to calibrate the model against some data that may be relevant. And also, and this links very well to what Milena was presenting just a moment ago, what we hope doing is to actually embed cognitively plausible decision mechanisms in the agents themselves. So we have completed 2 rounds of behavioral experiments using Amazon Mechanical Turk for the reasons that Milena mentioned. But if this works, that will be a nice way of integrating the different aspects of decision making in the formal model. So how does that, how to come back to the layers? What's our reflection on the ability to connect the different layers of the landscape through modeling? So I think that the main take-home messages are that first, the layers are interconnected, but there is the need for domain knowledge for all three layers. So different for physical, different for human, and different for information. And this is a great call for interdisciplinarity in such modeling endeavors. The second point is that actually the modeling offers quite a natural language for exploring the layers. So this is not only as a language, as a means of testing hypotheses, but also as a language of theoretical inquiry. And the more we are able to connect different methodological traditions, such as simulations and statistics, I hope to have demonstrated, even by looking at a data-free model, that statistical methods of analysis can still be useful in analyzing some of the outcomes, all the better. And given where we are, given where we are with the state of play in the different disciplines, I think now is a really exciting moment to engage in this kind of work, which is all the more important to get meetings. This one when you can see how different aspects of modeling connect in the context of landscape modeling. And with that,
Brilliant. Thank you very much, Jakub. That was, again, a very interesting talk. So do we have any new questions here? No questions at the moment. So, but I suppose, to me, I've seen Jakub speak on different subjects before. It struck me that the questions, to me, one of the big issues we have in landscape decisions, I think, is particularly if we're talking about very large scale landscape transitions to mass reforestation, the sorts of things that we saw in the first few days of these possible massive policy implications of Brexit and things like that, of mass changes in the British landscapes, is that the landscape decision makers who will be making those decisions will be dealing with enormous levels of uncertainty, which is, to me, always seem quite analogous to the sorts of stuff that Jakub was talking about, where people, if you're making the decision whether or not to migrate, it's hard to go back after you've made that decision. You're making the decision with enormous uncertainty, and that the rather cool techniques that Jakub's applied here, and that theory about why, that to bring together the various the theory about why people make decisions, how people make decisions under uncertainty, could be quite applicable in landscape systems. So again, I think it's a very interesting talk, Jakub. Very interesting to see it.
Yes, thanks for this comment, Felix. And I think that if there is a single lesson here, is that uncertainty is all pervasive, and as you rightly said, it comes out at a very many levels, from individual level decision making under the conditions of uncertainty. Part of it may be due to imperfect knowledge, but part of it may be just due to the fact that the world is uncertain and we can do nothing about it. And then on the top of it, we have uncertainty that comes from our attempts to actually model and possibly predict what might be happening. So all these components of uncertainty combine, and the challenge then becomes how to manage that. And of course, as a sort of committed Bayesian statistician, I would say that there are statistical methods that allow doing that. Although, of course, it may well happen that the ultimate outcome, the uncertainty, may well be overpowering. So this is the challenge that we are facing.
Yeah, and I also like the idea of using, it's been discussed before, of using these meta models as a way of understanding the ABMs, which I think that's one theme that's come across all 3 days so far is, the importance of ABMs. That ABMs well, they're so useful in many different applications of landscape decisions because you have these emergent behaviors that, so I thought it was quite interesting to see that even with a model that you built yourself without data, unexpected outcomes came out of the statistical meta modeling. It's quite an interesting result, perhaps non-intuitive, if I understood it correctly.
Yes, it wasn't intuitive, and it was. I mean, the results were slightly different when we just looked at one dimension at a time. So only by looking at the global sensitivity analysis, so all the parameters at the same time, we were able to identify these effects that I was talking about.
Yeah, thank you very much. Then, do we have it?
There is the whole.
Sorry, go ahead, Jakub. Didn't interrupt.
Just wanted to say that the point you made about meta models is quite important, because I think people too often think about ABMs just as black boxes. So the meta modeling offers a way of shining some light through the black box at the price of introducing an additional source of error that comes from meta modeling. But it's in my view, this is definitely something worth doing because it aids the analysis very substantial.
Do we have any other comments or hands on that? I think we are otherwise done for the day.